Very good morning to all of you. So, today's classroom discussion topic is there are the two topics which we are going to deal. First one is how can we differentiate the work and heat? What are the similarities and dissimilarities of the heat and work? And similarly, how can we define the path function and point function? So these are the topics which we are going to deal in this classroom. So these are very, very important one because in the previous class I told you that the energy transfer will takes place according to the heat transfer as well as the work transfer. So here the path function and point function definitions are very, very important one. So before going to study this particular topic, so why we have to study these topics? This is very, very important one. So that is, it is essential to know that in thermodynamics, why heat and work are not considered as a thermodynamic properties. So that is various thermodynamic parameters we are going to discuss in the engineering thermodynamics. All thermodynamic parameters we can treat it as the thermodynamic properties except work and heat. So why we should not consider the work and heat as an examples of the thermodynamic properties that you are going to study in this lecture. And similarly for each and every class, so we are having the objectives as well as the outcomes. So I've already told you the objectives of the today's class and the outcomes. So here the first outcome is, so you should able to identify the similarities and dissimilarities of heat and work after the completion of the class. And the second outcome is, so you should be able to explain the differences between the path function as well as the point function. That is the important one. So now how can we define the work? So because in the mechanics, normally we are having the definition of the work, that is the force into displacement. But here the work is defined as in the various forms, that is the displacement work and the is the PDV work. So that is, it is energy in transition across the boundary between the system and surroundings without the transfer of the mass. That is, in engineering thermodynamics, we are able to define the work. So that is, it is the energy in transition across the boundary between the system and surroundings without the transfer of the mass. So just now I told you that the work is basically defined as the force into is the displacement, that is the W is equivalent to the force into x, that is the dx. So force can be defined as is the pressure into area. So that's why we are able to define the work, the change in the work is equivalent to PdV. So the work is equivalent to the integration of is the PdV from the initial state 1 to the final state 2. And similarly here, what are the conditions? That is, it is the closed systems, no viscous effects, path is irreversible, gravity, magnetism, electricity concepts are neglected whenever we are considering about the displacement work or the PDV work. And similarly, how can we define the heat? So heat is nothing but it is energy in transition across the boundary between the system and surroundings without transfer of the mass. So that is, you can uh, clearly observe the definition of work and heat. It is basically depends upon whether the with the transfer of mass or without transfer of the mass. So that is, in the heat it is without transfer of the mass, but in the work it is taking place due to the transfer of the mass. So that is here, this transfer of energy is due to the temperature. So that is here, the heat transfer, it is due to the temperature difference. And the heat transfer to the system is positive because here the work and sign conventions are very, very important one. The work and sign conventions are very, very important one. The work done to the system, that is the work supplied to the system is always negative. The work done by the system is always positive. And heat transfer to the system is always positive. Heat transfer from the system is always negative. So the sign conventions are very, very important one. So that is, whenever we are doing some numerical problems based upon the work and heat, and only the sign conventions plays a vital important role. So which one is to be considered as minus and which one is to be considered as plus? That is very, very important one. So now, what are the similarities and dissimilarities between the heat and the work? That is the first outcome of the today's class. That is, both are boundary phenomena. So what do you mean by the boundary phenomena means? So this work and heat you are able to observe only across the boundary. So whenever a process is taking place, so that is the work is transferred from the system to the surroundings, or heat is transferred from the system to the surroundings, or from the surroundings to the system. That is, these are the two parameters which we are able to observe across the boundary only whenever a process is executing. So that's why it is known as the boundary phenomena. And the another one is both are in transient form of the energy. Both are in the transient form of the energy. That is, whenever a process is taking place only, we are able to observe there is some work interaction is taking place and heat interactions are taking place. That is, the transit is nothing but in motion. In motion, that is, whenever a process is executing only, we are able to observe the work and energy across the boundary, and these are the transient phenomena. And here I told you that both are the examples of the path functions only. So that is, the path functions means these are dependent on the path followed by the system. So these are independent on the states of the system. So that's why these are dependent on the path. If the path is varied, then the work varies, and similarly heat also varies. So that's why the path function means it is dependent on the path followed. So that's why these are not thermodynamic properties. So that's why I told you that the path functions are not considered as an examples of the thermodynamic properties. All point functions will be treated as an examples of thermodynamic properties, but not path functions. So that's why we are able to say that all thermodynamic properties are point functions. And whenever I am saying that is a path function, these are inexact differentials. So this cannot be a perfect or exact differential. That is, you cannot write down the work as dW. So you can write it as a delta W only. That is, it is inexact or imperfect differential. Similarly, delta Q, don't write dQ. But whenever we are writing down the enthalpy difference, we can write it down as a dH. Enthalpy difference, ds. Because enthalpy, entropy, volume, dV, dP, pressure, these are all thermodynamic properties and point functions. These are exact differentials. So that's why we can differentiate the similarities and dissimilarities about the work and heat. So just now I told you that the sign conventions are very, very important one. So that is the work done by the system. So here the work done by the system is always positive, and work transfer to the system is always negative. Heat transfer to the system is always positive. Heat transfer from the system is always negative. So the second outcome here is how can we define the path function and how can we define the point function? What are the differences? So I've already told you that is the path function is nothing but, so it is dependent on only on the path followed by the system. So it is independent on the initial state as well as the final state. So that's why you cannot write delta dq, it is equivalent to q2 minus q1. You cannot write down because it is an inexact differential or imperfect differentials. So whereas in the point function, these are the exact or perfect differentials. So you can comfortably write down dv is equivalent to v2 minus v1 because point functions are not dependent on the path. So whatever the path you follow, so that is these parameters will not affect. So these are only dependent on the initial state as well as the final states of the system only. So that is the difference between the heat transfer and work transfer. So just now I told you that. So just you can observe here, that is when the work is said to be positive. So that is when the work done by the system, then it is said to be positive. Then the work transferred to the system, it is always negative. What are the units for the work? So it is normally the SI units are is a Newton meter because the W is equivalent to force into displacement. So the force unit is Newton, displacement unit is the meter. So Newton meter is normally known as joule. So 1 joule is equivalent to 1 Newton meter. So that is the unit for the work. So these are the topics, that is now we clearly studied the differences between the work and heat, that is the similarities and dissimilarities, and similarly how can you distinguish the path function as well as the point function. So with this heat and work and point function and the path function concepts, so let us see, so what type of the questions were asked in the previous competitive examinations. So it is a one sample which is given in the 2016 set 1 gate examination question. So the question here is, which of the following statements are true with respect to the heat and work? First one, they are boundary phenomena, they are exact differentials, they are path functions. So I told you that these are inexact differentials because these are the path functions. So you can comfortably answer which one is the right. So the answer is B, that is both 1 and 3. That is both are boundary phenomena, it is right. And both are path functions, it is right. But these are exact differentials, it is wrong because it is inexact differentials. That's why you can comfortably say the answer is B. So you can see the next question, that is match the following. So here also it is based upon the heat and work. So which one will be the appropriate one for the heat and work? So that is the ABCD options are given. So you can see comfortably based on this particular one. So that is E stands for heat and F stands for work. So here heat, that is when added to the system. So that is when heat transfer added to the system is always positive. Work added to the system is always negative, already we discussed. And both are inexact differentials, already we discussed. Both are path functions, already we discussed. Both are boundary phenomena and both are transient phenomena. So just whatever the concepts what we discussed in the today's class, so exactly you can answer it as the D is the right answer based on the work and heat. And similarly now you can answer, it is one of the typical question that is based upon the triangular concepts, that is what is the area of this particular the triangle. Now you can answer, so that is how can you find out the work transfer. So that is the answer is A and E. So that is another one is in a frictionless piston cylindrical assembly, a gas undergoes a process such that its pressure varies inversely with the cube of its value. That is P is inversely proportional to V cube, that is 1 by V cube. The initial pressure inside the cylinder is 5 bar and the gas occupies 0.1 meter cube. The gas is compressed slowly and its final pressure becomes 15 bar. Then what is the work interaction? So the answer is minus 27. So similarly here the another gate question is, a frictionless piston cylindrical arrangement contains gas. The gas undergoes quasi-static expansion and the piston moves upwards. Which of the following represents the infinitesimal work done by the gas? So the answer is A, it is F into dl, where F represents the force acting on the piston and dl represents the infinitesimal piston displacement. It's a simple one, that is the work is equivalent to the force into displacement. So that is the answer is A. So like this we can answer some of the questions which are based upon the work and heat and point function and path function. So these are very important one in the engineering thermodynamics point of view. I hope understand the concepts very comfortably. So thank you very much for listening this lecture, and we will meet you once again in the next classroom discussion topic. Thank you.